Hi there. Today we are going to talk about the adapter design pattern. The term adapter should be familiar to all of us. We have used adapters in some form or the other. The simplest example is the electric socket. In India, we have a specific standard for these electric sockets, but that standard is different from the European and the US standards, because of which, when we travel abroad, we have to carry an adapter along if we need to use these electric equipments that were bought in India. The same goes for US and European nationals too. When they travel to India, they have to bring along an adapter or buy an adapter from here. Nowadays, we use a lot of electronic equipments. For example, the smartphone. In my case, I use a smartphone that has a C port. It only has a C port. So if I have a headset that uses a 3.5 jack, I won't be able to use it directly. So what I have to do, I have to buy an adapter that converts or it interfaces with the 3.5 adapter and then converts it into a C port. So this is some layman explanation to what an adapter is. But where exactly is the use of an object-oriented adapter? So we are going to look at what exactly or how exactly we can create an object-oriented adapter and where are we going to use them. So before we move forward, two important design principles that we have already talked about in the previous videos. One design principle, program to an interface, not an implementation. The second design principle, favor composition over inheritance. So always keep these two design principles in mind. We are going to use the same socket example that we discussed before for describing an adapter pattern in object-oriented terms. So there are two interfaces. One is going to be the US interface and the second is going to be an Indian interface. So let us start coding. So as specified, we have created two interfaces, one for the Indian standard and the second thing for the US standard. Now let us add some functionality to these two interfaces. We are going to give three methods to each of these interfaces. We will start with the Indian standard first, and then we will move on to the US standard. So you can see we have given three methods to the Indian standard interface. One is the female round socket that represents the Indian standard, and then for the switch on and the switch off method. Now we are going to copy paste the same methods to the US interface and just change just one of the method names. So what we just did was just to copy the three methods that we gave in the Indian standard interface and then pasted into the US standard interface. And just we renamed one of the methods, that is from the round, we changed it to rectangle because that is the standard that is followed by the US socket interfaces. Next, we are going to have two implementations of these two interfaces. And we will give some names of some companies that actually give implementation of the sockets. Implementation in the sense the actual socket. So we will have for the Indian socket the Havels. So here is the implementation of the Indian standard. I have given the name of the company as Havels, which is an Indian company that manufactures sockets and all. So you can see the three methods has been implemented. Of course, just some system printing to the console just to depict which is the socket being used currently. So for the round socket interface will come, and then of course when somebody switches on, we will just print out, and that's the same for switch off too. Apart from this, we have overridden the two string method just to depict which is the type that is being used when we actually test the particular application. The next thing that we are going to do is to implement the US standard, and there is a US company called Bryant, which is the name that we are going to use to implement the US standard. So we have completed our coding. The next thing is to test it out. So we will be only testing the interface for the time being. As a recap, we have created two interfaces, one for the Indian standard, the second was the US standard. We have two implementations, one for the Indian standard, which we gave the name as Havels, and the second was Brian, which is an implementation of the US standard. Now we are going to test it out. So we just tested the code that we just wrote, and of course based on the output we can see that the code is working fine. So the initial these three output is because we used the Indian socket Havels, and these three output came because the Brian we used the US standard interface. Now is the scenario: me or somebody else from India is going to travel to US, and he is taking this Havels with him. So you can see things won't work. Why? Because Havels is of the Indian standard interface, and of course in US they uses the US standard. So how can we adapt this particular Havels, which is an Indian standard interface, to a US standard? That is where the adapter pattern comes. So how do we design the adapter? Well, the answer is simple: to which interface we are going to adapt to. So you can see here that we are going to adapt the Indian standard plug to the US standard. So we are going to create an adapter that implements the US interface. So let us start creating the adapter. For that, I'm going to create a new package, and then I'm going to give a name for the adapter because we are going to use a US adapter. I'm going to give the name as US adapter, and which is the interface this adapter should implement. This the US standard interface that this adapter. Why? Because we are using an Indian standard plug that should go into the US standard. So we are going to use a US adapter that implements the US standard, and then implement the methods. So here we are going to remember one more design principle, or one design principle that we have already talked about. We favor composition over inheritance. So what we are going to do here, we are going to compose this US adapter with an Indian standard like so. So think like this. We have to adapt the Indian standard to US standard. So we are creating an adapter that adapts the Indian standard to the US standard. So why we are encapsulating this Indian standard? Because whenever somebody uses this adapter, and the adapter caters to the US standard interfaces, the female rectangle socket, the switch off, the switch on, all these methods are for the US standard. When the US standard gets called, internally the Indian standard will use those functionality. So how we are going to use that? I will just print it out here. That means the US socket is used by, and then I will just buy the Indian standard. So when somebody creates a US adapter, in the sense, literally, if you ask me, somebody takes a physical US adapter and then plug into the female rectangle socket, which is the functionality of the US adapter. And if somebody is carrying the Indian standard, when they create the US adapter, of course, but one thing what we have to do, let us create a constructor that takes this particular US standard like so. So when somebody carries the US adapter, which has which for they have the plug and that's an Indian standard, they will use the US adapter, and then they use the Indian standard along with the US adapter. So when they use the US adapter and plug that US adapter into the female rectangle socket, it internally uses the Indian socket to pass on the functionality. In this case, the electricity flowing from the female socket will go through the plug and enter the electric equipment of the Indian standard. The same thing goes for the switch on too. So the Indians, so when the switch on of the US standard gets called, it is internally it is the Indian standard that switch on that will get called, and that is the same thing for the switch off too. We will give Indian standard dot switch off like so. This is all there is for the adapter pattern. So what we just discussed is to understand how to create an adapter, to which interface are we adapting to. So we will implement that particular interface. Which is the interface that we need to adapt? We encapsulate that particular interface. That's all we need to understand. If it is the other way around, if if somebody is traveling from US to India, you just need to implement, instead of US standard, you will implement the Indian standard, and then you will encapsulate the US standard. The last thing, let us use this particular adapter. So what we are going to do, first let us give an output just to separate the previous output, and then so traveling to US with Havels, and then of course what are you going to do, and we are going to take a US adapter along that will use the Havels plug. Let us then use the US adapter like so. And now what exactly we are going to use the US adapter and then use the female rectangle socket like so. And then we will use the US adapter dot switch on, and then the US adapter dot switch off like so. Again, reiterating, we created the US adapter to adapt our Indian standard plug to the US adapter. So whenever use the US adapter, when we call the female rectangle socket, which is and the functionality of the US standard, internally it uses the Indian standard to convert that particular functionality. Let us see whether the theory is correct or not. So we can see here we are now traveling to US with an Indian standard equipment, and we have already taken a US adapter too. So then when we start using the US adapter, Internally, the US socket is used by Havells India. And of course, you can see the power switched on in the Indian socket, even though the switch on was done in the US adapter. So you can think of it as the electricity flowing from the US socket to the Indian plug and to the Indian equipment. This is the adapter pattern for you. To sum up, let us give a definition to the adapter pattern. The adapter pattern converts one interface into another interface that the client expects. To simplify it further, adapter lets different classes work together that couldn't otherwise because of incompatible interfaces.